Okay, hello everybody. I will do a quick introduction on what is PACE and why do we organize this webinar. And I can see on the list of participants that many of you are not PACE members or not familiar to PACE activity. So I will start with e-waste and the Basel Convention. It became an e-waste priority waste stream under the Basel Convention in 2002. And in 2006, through the Nairobi Declaration, we started some partnership on e-waste. And the first one was the Mobile Phone Partnership Initiative that is now closed. And following it, we started with the PACE. PACE is the Partnership for Action on Computing Equipment, and it started in 2008. It is a multi-stakeholder forum for manufacturers and recyclers, for international organizations, for academia, for NGOs and the governments. There is around 100 members of PACE, which can be divided in different categories, and there are 25 from parties or signatories to the Basel Convention, 11 from Basel Convention Regional Center, 9 research and academic institutions, and around 15 NGOs, industry and industry associations. Here is a picture of some of the PACE members. The PACE members usually meet once a year through what we call the PACE Working Group, which is the decision body of PACE. So the mission of the PACE is to increase the environmentally sound management of used and end-of-life computing equipment, taking into account the social responsibility, the sustainable development, and promoting information sharing on life cycle thinking. The scope is personal computers and associated displays, printers, and peripherals. And the working principles under PACE are first to promote a dialogue amongst different actors like government, industry, NGO, academia. Secondly, to seek for innovative solutions. And thirdly, to do some coordination and cooperation as appropriate with the other bodies involved in e-waste activities. Talking about activities, there are many different ongoing activities under PACE. First of all, at the last conference of the Party of the Basel Convention, 2 technical guidelines were adopted. It is the 2 ones that you have here written. In parallel of that, we have some pilot projects that are ongoing. And the purpose are to test our technical guidelines and then to receive some feedbacks and to adapt our technical guideline accordingly. And we also have some awareness raising and training activities. And for example, this webinar today is organized through the project group in charge of this awareness raising activities, or we also have some different workshops in different regions of the world. The main output of PACE will be the guidance documents on environmentally sound management of used and end-of-life computing equipment. And it will be a summary of recommendation and proposal from the different technical guidelines and documents that we are working on. namely the two guidelines that were showed to you, but also a report on environmentally sound management criteria recommendation, and the glossary of terms that was also adopted at the last COP. I will stop my presentation here, and just to let you know that this webinar today is a replica of a webinar that already was held in September, and we had at this webinar 2 presenters. But today, to make it a bit shorter, and because of the density of information, we have only one of the presenter, and the second presenter will do her presentation the 19th of December. But you can find all this information on the Basel website. Thank you very much.
Thank you, Patrick, for your presentation. We will directly move on to the second presentation, which will be made by Ms. Corey Ong. So, Ms. Ong, you have the floor. You can go ahead.
Thank you for inviting TES-AMM to this webinar. Good morning, good afternoon, and good evening to everyone. Today, we would like to share with you the key processes in our facilities for material recycling and recovery of e-waste. In terms of material sources, we have 2 main channels. One of them is from the end users or consumers, where we collect disposed electronics through take-back programs initiated by the brand owners, or sometimes through electronics trade shows, where consumers will trade in their used products for some vouchers to buy the new electronics. And of course, another source is actually from the manufacturers or factories directly, where we collect the disposed or obsolete surplus components from them for recycling. We have 2 key process flows to manage all these materials. Let's first look at the process flow for used electronics going for reuse. Upon uplift request initiated by the customers, we will review the list of products against our material acceptance policy for conformity. Once approved, we will coordinate with the respective customers for collection. Once the materials are received at our facilities, there will be a check in process where customers' details, the agreed process SOPs, product information will be verified. Thereafter, we will send the materials to the various processes, like what you see on the screen there. It can be a screen and test, repair and refurb process, or testing. For the whole units or components which ultimately pass the final QC, they will be remarketed. And for those which are so-called beyond repair, they will be sent to our end-of-life electronics recycling processes. The materials sent to our end-of-life electronics recycling process will first be weighed in, sorted, and categorized to type. You will see 3 main streams, namely the plastic, metal, and electronics. For plastics, we will actually further segregate to type into the plastic family, weigh and record, some to store for sale, and some to direct to our waste plastic recycling process. The metals will also be further segregated to ferrous and non-ferrous, weigh, record, and store for sale. For electronics, there are 2 separate processes to it. We will first determine whether they have hidden or apparent precious metal plated on their surfaces in order to direct them to appropriate processes. We are also required by the local environmental authority in the country that we operate to put in place effective pollution control equipment to ensure safe emissions and discharge throughout our processes. Here we take a closer look at the demanufacturing process. The example given in this slide is for cell phones. We will dismantle and segregate these materials to their component streams. You can see examples like plastic casings, the PCBs, LCDs, etc. There will be general waste stream as well, because all these cell phones will actually arrive in different packaging. So for all the cartons and the trays, we will also segregate and actually have them recycled properly. Here are some examples of our mechanical processes. Example of equipment shown here will be a crusher, hammer mill, and electrostatic separator. Electronic components will go through crushing to reduce them into smaller fragments to prepare for hammer milling. Thereafter, the materials were now in particle form will be sent to the electrostatic separator for further segregation of metallic and non-metallic. The next stage is our chemical processing. Processing here are actually chemical stripping using cyanide, electrolysis, and precious metal refinery. I will further illustrate this process. This is an example of materials of apparent precious metal, such as gold, plated on your surface. In the first picture, you see that see a lot of yellowish component, so-called plating on the surface of all these components. These are what we call apparent gold, and they will be sent for this stripping in chemical bath to remove the plated gold on their surface. Thereafter, this chemical bath with so-called gold components will be sent to electrolysis process to so-called harvest the gold flakes in their raw and unprocessed form. Then these gold flakes will again go through a further chemical refining into gold powder to a few more stages, and finally recover the finished product, which is a gold ingot. And the gold ingot which is recovered is about up to 99.9% purity. And for those after strip so-called components, we don't jump them right away. We will transfer them to our hidden gold and base metal recovery process, where they will go through a series of crushing, hammer milling, then electrostatic separator again, before they will come back to the chemical process for further processing. This is our waste plastic and imaging consumable recycling process. Here the term EPC refers to epoxy plastic composite pellet fabrication process. So the following two slides, this and the next slide, will actually focus on explaining to you how we actually recycle waste plastic in our facility. Here you can see that selective type of plastics will be channeled to this process. In respective plastic family here, such as engineering plastics, your spent epoxy runners, your waste plastic, materials will be crushed separately to generate various streams of crushed flakes. And further size reduction and moisture elimination will take place for all these crushed flakes. The materials ready for pellet fabrication will be the waste plastic and epoxy powder, as well as engineering plastic pellet or granule. The three types of materials on earlier stage will be blended in defined proportions with our proprietary bonding agent. The final product will be the customized EPC pellet. However, this process, we actually have not commercialized it. It's actually for internal usage in our warehouse. A few reasons given feedback by our customers or partners that we have is that they still prefer using wooden pallets, and EPC pellets are actually more brittle and heavier, and the cost of fabricating them actually at very low volume is very high. And for us, it's also there is one challenge: it's not easy to always get the right mix of plastic and type of epoxy for the process. So for this process, we actually do continuous R&D, and we are currently actually working with industry polymer experts and even local polytechnic to explore new methods in making this product better, and maybe can be commercialized in the near future. So for the lithium-ion batteries recycling, this is the pioneering and the first in actually Asia. Then the process stages are shown in this slide. The process output, such as the paper, plastic, and copper foil, will be sent for further recycling, while the black mass, essentially containing copper, nickel, cobalt, steel, and lithium, are sent to our smelting partners for further processing. In terms of pollution control, we have equipment such as the cyclone dust collector. It is a closed loop system because we have crushing, hammer milling, and electrostatic separating process. So this is actually good for collecting the dust particles emitted during the mechanical process stages and to minimize the dispersion in the environment. Then we have the scrubbers, acid and cyanide scrubbers. This one actually treats the spent chemical solutions and fume discharged during the chemical processing stages. We also see the toxic gas control panel, wall-mounted gas detector. These are our toxic gas monitoring system. We monitor the processing room environment during the chemical process. If there should be any leakages beyond certain limit, a siren will be initiated and workers will be evacuated from the affected areas. We also have our own in-house wastewater treatment plant to ensure that the wastewater generated from the processes are treated to a safe discharge level as stipulated by local authorities. And because we have our own wastewater treatment plant, our Singapore National Environmental Agency also required us to actually set up a last IC, so-called last inspection chamber pH monitoring system. This one actually will monitor the pH value of the wastewater discharge. And if the pH value falls below 6 or rise above 9, it will activate and shut the gate valve so that it will prevent wastewater from discharging out to the public sewer. For all the disposed electronics received at TES-AMM, we will also carry out data security management processes. You have data sanitization, you have degaussing. We also have physical destruction for the media containing all the sensitive information. So customers also require us actually to have complete traceability. So we have a few mechanisms in place. We have our e-waste tracking system, or e-WATS. The main language that we have is in English, and for our sites in China, we have it in Mandarin, so that the system is actually only accessed by authorized personnel. We also implement inbound tagging system in our facility. Materials will be issued with a unique load number to track trace upon collection throughout the processes. So each inbound load number is unique to the country. Like the one that you see on the screen starts with a 65. 65 is the country code of Singapore. So it's easily identify the materials actually received by Singapore. We also actually generate auditable reports for customers, authorities, whoever so-called the entrust of materials for our processing. It's a full documentation trail, like log sheets, reports and destruction certificates for onward reporting and audits by the respective stakeholders. It can be authority, customers, and third-party audit firms as well. All the TES-AMM facilities must be equipped with valid local operating licenses and be certified with the highest industry standards. As we operate in more than 20 countries globally, we also align ourselves with international compliances such as the Basel Convention, and we work very closely with respective environmental authorities on notifications, permit applications. Thank you for your time. Should you have any questions, please feedback or email to the webinar organizer to us.